Hi class, today our topic of discussion is logarithm. This is lesson 2, lesson 1. We have already done where we saw that exponential form can be written in log form. How? A to the power n equals to b, where a is a positive real number not equal to 1, can be written as log of b base a equals to n. Now in this lesson, we'll look at all the properties of logarithm and then we'll solve some. Look at the first property. Log of a base a equals to 1. Now how this? Look over here. Suppose log a base a is equal to x. Then in exponential form, can I write a to the power x equals to a? Which means can I write x equals to 1? Which means this is nothing but 1, which implies log of a base a equals to 1. If you're finding the log of a number with the same base, then it becomes 1. Log of 2 with the base 2 is 1. Clear? Let us look at the next property. Now look at second property, which says as log of 1 to any base. Of course, a not equal to 1 and a is a real positive number will be equal to 0. How come this? Look over here. Suppose I take log base a 1 as x. So in exponential form, can I write a to the power x equals to 1? Which I can write a to the power x equals to a to the power 0, which means x equals to 0. So this becomes 0. So log of 1 to any base except 1, okay, is 0. The base cannot be 1, okay, and it has to be a real positive number. Now look at the next property. Look at the third property. Log mn to the base a is equal to log m plus log n with the same base. How come? Look over here. Suppose I take log m base a as p and I take log n base a as q. So in exponential form, it will be a to the power p equals to m, and this will be a to the power q equals to n. Now you multiply these two. So if you multiply these two, it becomes mn equals to a to the power p multiplied by a to the power q equals to a to the power p plus q. So your mn is equal to this. Now if you change this exponent in log form, what you will get? Log mn base will be a equals to p plus q, and we know what is p plus q. Your p is what? Your p is log m base a plus, and q is log n base a. So log mn equals to log m plus log n with the same base. Clear? And note carefully, log mn base a is not equal to log m into log n with the same base. This is not equal, okay? What I mean over here, for example, if you have log 6 base 2, so we can write log base 2 plus log 3 base 2, because 6 can be written as 2 multiplied by 3. So it will be log 2 with the base 2 plus log 3 with the base 2. Now we look at the next property. Now our next property is log m by n to the base a is equal to log m minus log n with the same base. How? Just look over here. Suppose log m base a you take as p and log n base a you take as q. So can we write a to the power p equals to m, and can we write a to the power q equals to n? Now you divide these two, m by n, okay? So m by n equals to a to the power p by a to the power q, which is equal to a to the power p minus q. Now we got what? M by n equals to a to the power p minus q. Now when you change this to logarithmic form, you get log of m by n to this base a is equal to p minus q, and you already know what is p. P is log m base a minus log n base a. What I mean, suppose you have log base 6 and you have 5 by a. So you can write this as log 5 base 6 minus log a base 6. Is it clear? Be careful. Log m by n with the base a is not equal to log m by, it's not equal to, okay? They are not equal. Log m by n is log m minus log a. Now we look at the next property. Now look at this property, the fifth one. Log x to the power n with the base a is equal to n log x base a. The power comes in front of log. How? Suppose I take log x base a as m. So in exponential form I can write a to the power m equals to n. Now I can write like this, x to the power n. Okay, raising both sides to the same power, okay? So this will be a to the power mn equals to x to the power n. Now again converting this to logarithmic form, what I'll get? Log base a x to the power n equals to mn. Am I clear? Now look carefully. So log base a x to the power n equals to m n n, and what was m? M was log x base a. Done. Which means something like, if you have log 2 cube base is 2, so we can write this as 3 log 2 base 2, and this we know is 1. So the answer is 3. Okay, now we look at the next property. Now look at this property, the base changing rule. Very important. Log a to the base c is equal to log a by log c with some different base of our choice. You know how this came? Look over here. If I take log a base c is equal to x, in exponential form can I write c to the power x is equal to a? Now I'll take log on both sides with our choice of base. So this becomes log c to the power x. Suppose the base is b, and this becomes log a and base is b. Now this we know the power comes in front. We have done it. So x log c base b is equal to log a base b, which means x equals to log a by log c with the same base b. Okay, and x is what? X is this, which means we can say log a base c is equal to log a by log c with a different base, isn't it? We can say this. Okay, which means suppose you have something like log 2 base 3, so you can write this as log 2 by log 3 with a convenient base. Okay, now we look at the next property. Now look at this property. Log of x base is written in exponential form, a to the power n, that is equal to 1 by n log of x to the base a. How? Just look over here. We have log x and the base is a to the power n. Now by base changing rule can I write log x by log a to the power n to a suitable base b? Now this can be written as log of x base b. N comes in front, so n log of a base b. Now look carefully, 1 by n, and this again log x by log a with the same base can be written as log x with base a with the base changing rule. Okay, what I mean, suppose you have log 10 to cube, so this will be 1 by 3 log 10 and base 3. Am I clear? Now we look at the next property. Now look at this property, very easy. Log 1 by n to the base a is equal to minus log n to the base a. How? Just look over here. Log 1 by n base a can be written as log n to the power minus 1 to the base a. Now we know minus 1 comes in front. Okay, so this is log n base a. What I mean, suppose we have log 1 by 5 to the base 10. This can be written as minus log 5 to the base 10. Clear? Now we look at the next property. Now look at this property. A to the power log m base a is equal to m. See, the base of the exponential form and the base for the log form is same, so it becomes m. How? Just look over here. I'll take log a to the power m as x, suppose. So this we can write a to the power x equals to m. Now again you put the value of x, so a to the power log m base a is equal to m. Done. Clear? Now look at this one. Log of a to base b is equal to 1 by log of b base a. How come? Very easy. Log of a base b can I write by base changing rule? Log a by log b. Suppose we take the base as c. And this is 1 by log b by log a base is c. Okay. Then this, again by base changing rule, we can write this as log b base a. What I mean, if you have something like suppose log 2 base 3, you can write 1 by log 3 base 2. Clear? Now we look at sums from ML Agarwal exercise 9.2. Now look at this. Simplify. Sum number 1 part 1, log a cube minus log a square. Now can I write by this, the power comes in front, so 3 log a minus 2 log a. Okay. Now 3 log a minus 2 log a is nothing but log a. Done. Now look at sum number 1 part 3, which says that simplify log 4 by log 2. In both the cases, the bases are missing, which means the base is nothing but 10. Now log 4 can I write as log 2 square by log 2. Again this power comes in the front, so 2 log 2 by log 2. So this log 2 entirely cancel. Of course, log 2 not equal to 0. So this is equal to 2. One thing, if something is like log 2 by log 3, you can't cancel simply log. The entire thing can cancel if they are same. Okay. Now we look at the next sum. Now look at 1 part 5, log 27 by log root 3. Base is not there, which means the base is 10. Now 27 can I write 3 cube, and root 3 can I write 3 to the power half. So this power comes in front. This is 3 log 3 by half log 3. Of course log 3 cancels out. Of course log 3 not equal to 0, and 3 divided by half will be 6. Done. Any problem? Now look at sum number 6, which says log 9 minus log 3 by log 27. Easy. Now log 9 can I write log 3 square minus log 3, and log 27 again I can write as log 3 cube. Now this, the power comes in front, so 2 log 3 minus log 3 by 3 log 3. Now 2 log 3 minus log 3, 2x minus x is x, so this will be log 3 by 3 log 3. Now this cancels out. This is 1 by 3. Of course log 3 not equal to 0. Clear? Now let us see the next sum. Now look at this sum. Very easy. Simplify 2 plus half log 10 to the minus 3. Now we can write this as 2 plus this minus 3 comes in front. Okay, so minus 3 by 2 log of 10. We know the base is not given, which means the base is 10. We know the value of this is 1, so we can write this as 2 minus 3 by 2 multiplied by 1. So that's 2 minus 3 by 2. So that's 2. 4 minus 3, that's half. Remember, the base is 10. Log 10 is 1. Log 100 is 2. Log 1000 is 3. And so on, provided the base is 10 in all the cases. Okay. Now we look at the next sum. Look at 2 part 7. Simplify log 2 plus 16 log 16 by 5 plus 12 log 25 by 24 plus 7 log 81 by 80. We need to express it in single log. How? Just see. This is log 2. This becomes the power. So this is log 16 by 15 whole to the power 16. Plus similarly over here log 25 by 24 whole to the power 12. And this is log 81 by 80 to the power 7. Now see, log a plus log b plus log c plus log d. We can write a single log a multiplied by b, which is 16 to the power 16 by 15 to the power 16. Similarly, this will be 25 to the power 12, 24 to the power 12, and this will be 81 to the power 7 and 80 to the power 7, isn't it? Now look carefully. 16 we can write 2 to the power 4, isn't it? And 15 is 3 multiplied by 5 to the power 16. 25 I can write 5 squared to the power 12, and 24 I can write 8 into 3, which is 2 cube multiplied by 3 whole to the power 12. 81 I can write 3 to the power 4 to the power 7, okay? And 80 I can write 16 into 5, which means 2 to the power 4 multiplied by 5. Am I correct? I'll open the bracket. So this is 2 to the power 64. This is 5 to the power 24. This is 3 to the power 28. And in the denominator, what we have? We have 3 to the power 16, 5 to the power 16, 2 to the power 36, 3 to the power 12, 2 to the power 28, and 5 to the power 7. Okay? Now look carefully. Log. Now 2, 2, and 2, and 2 over here. Bases are same. We can add 64 plus 1, 65, and minus 36 and minus 28, which means 1 is left. So only 2 will be left. Look at 3. 3 to the power 28, and this is 16 and 12, 28. So 3 to the power 28 minus 28. So only 3 is, sorry, it will be 3 to the power 0. 3 to the power 0 matlab 1. And look for 5. This is 24 minus 16, 8. 8 minus 7, 1. Which means 5 to the power 1, which means 5. We have already done this in exponent. So this is log of 10. We know the base is 10 if it is not given. So this is 1. So that's my answer. Clear? Now we look at the next sum. Now look at 2 part 5. 2 log 2 plus log 5 minus half log 36 minus log 1 by 30. The base is 10. Okay. Now in this type of sum, try to bring entire thing into single log. For that, see that the coefficient of log is 1. Now how to remove this coefficient? This becomes the power. So this is log 2 square plus log 5 minus log 36 to the power half minus log 1 by 30. Isn't it? Now this is log 4 plus log 5 minus 36 to the power half means root 36. Root 36 is nothing but 6. So this is log 6 minus log 1 by 30. Now log a plus b. So these two will be multiplied. And this is minus and this is minus. These two will be divided. So in single log, can I write at once 4 multiplied by 5 divided by 6 divided by 1 by 30? Look carefully, isn't it? So this is what? Log. This is 4 into 5 into 30 by 6. This is 5 times. So this is log 100. Now we know the base is 10. We can write as log base 10, 10 square. So this is 2 log 10 base 10. And this is 1. So 2 ones are 2. Okay. Remember, log 10 will be 1. Log 100 will be 2. Log 1000 will be 3. Like this. Okay. We can directly use the value. If somebody writes from here directly 2, that's also correct. Okay. Now we look at the next sum. Now look at sum number 3. Express a single log. Half log 25 minus 2 log 3 plus 1. 3 part 4. Same logic. Okay. This becomes log 25 to the power half. This 2 becomes power. So log 3 square. And 1 we can write log 10 because the base is 10 in all the cases. Now this is log 5 minus log 9 plus log 10. Now in one step we can write in single log. See, 5 into 10 because they are added. And this is subtracted, so it will be divided. Okay. So this is log 50 by 9 base 10. And that will be my answer because we can't simplify this Okay, we'll keep it till here. Now look at the next sum. Now look at 3 part 5. Same. We can write this as log 9 to the power half plus log 3 square minus log 6 plus log 2 minus 2 we can write as log 100. Of course the base is 10 in each case. Now this is log 3 plus log 9 minus log 6 plus log 2 minus log 100. Similarly, we'll express it in single log. How? The ones which are added gets multiplied and the ones which are subtracted gets divided. The base is 10. So that's how much? That's log base 10, 9 by 100. We can find the value of this if the log table is given. Okay. Till now you can leave the answer here only. Okay. Now we look at the next sum. Now look at this sum. 4 part 1. Prove log 4 divided by log 2 equals to log 9. Over here the base is 10, 10. Over there the base is 3. We'll take it LHS. LHS is what? Log 4 divided by log 2. Now this I can write log 2 square divided by log 2. This I can write 2 log 2 by log 2. The bases are 10. So this cancel, of course. Log 2 not equal to 0, which means this is 2. Now I'll solve RHS. RHS is log 9. The base is 3. Be careful. So this, can I write log 3 square base 3? So this 2 comes in front. 2 log 3 base 3. Now look carefully. Log of 3 base 3. These two are same, which means this becomes 1. So this becomes 2 multiplied by 1. That's 2. So LHS equals to RHS, you can say, verified. Isn't it? Now we look at the next sum. Now look at this sum. Given x equals to 100 to the power a, y equals to 10,000 to the power b, and z equals to 10 to the power c. Express log 10 root y by x square z cube in terms of a, b and c. Look carefully. First, x is given as 100 to the power. Take log on both sides. So log x equals to log 100 to the power a. Okay. So log x equals to a comes in front. Done. Okay. And log 100 is 2. So log x equals to, this is 2. Okay. The base is 10. Okay. Look at the second one. Y equals to 10,000 to the power b. Taking log on both sides. So this becomes log y equals to log 10,000 to the power b. B comes in front. So log y equals to b log 10,000. So log y equals to b. And 10,000 is how many zeros? 4 zeros. So log 10,000 will be 4. The base is 10. So we can directly write this as 4b. And the last one is log z equals to log 10 to the power c, which means log z equals to c log 10, which means log z. Log 10 is 1. So this is c. Okay. Now look. Okay. They have given log 10 root y by x square z cube. Single log. Will expand it. How? The ones which are multiplied in the numerator gets added up. So this is log 10 plus log root y. Root y, can I write y to the power half minus the denominator gets subtracted, log x square minus log z cube. Now look carefully. Log 10 is 1 plus half log y minus 2 log x, the power comes in front, minus 3 log z. No, we know the value. 1 plus half. Log y is how much? 4b minus 2. Log x is 2a minus 3. And this is c. So we get 1 plus 2b minus 4a minus 3c. Clear? You can pause the video and see the sum. Okay. Now we look at the next sum. Now look at sum number 8. Given x equals to log 3 by 5, y equals to log 5 by 4 and z equals to 2 log root 3 by 2. Find x plus y minus z and 3 to the power x plus y minus z. Easy. First one, x plus y minus z. Can I write, instead of x, I can write log 3 by 5 plus, this becomes log 5 by 4 minus 2 log root 3 by 2. Now this becomes log 3 by 5 plus log 5 by 4 minus this 2 becomes square. Okay, so this becomes root 3 by 2 whole square. Okay, the coefficient becomes a part. So this becomes log 3 by 5 plus log 5 by 4 minus log. If you look carefully, this is 3 by 4. Root 3 square is 3. 2 square is 4. Now we'll express this as single log. The ones which are added gets multiplied and this one get divided. So log 3 by 5 multiplied by 5 by 4 divided by 3 by 4, isn't it? So this becomes log 3 by 5 multiplied by 5 by 4 multiplied by 4 by 3, the reciprocal. So this cancels out. So this becomes log 1 base 10. Now we know log 1 will become 0. Okay. Now the second part is very easy. So this becomes 3 to the power 0. So this becomes 1. Both the, in the first part the answer is 0. In the second part the answer is 1. Clear? Now we look at the next sum. Now look at sum number 10. If log v plus log 3 equals to log pi plus log 4 plus 3 log r, they have told express v in other quantities which are there over here. Simple. Express both sides as single log. Okay. So this becomes log v plus, I'm just writing it, log 3 equals to log pi plus log 4 plus, this we can write log r cube. Now if you write this as single log, this becomes 3v. Okay, and this becomes log 4 pi r cube, isn't it? Which means the base is 10. Okay, now both side log is there, the base is same. We can equate this also. If log x equals to log y, then we can say that x equals to y, provided the base is same. So we can say that, or you can say taking anti-log, whatever. So 3v equals to 4 pi r cube, which means v equals to 4/3 pi r cube. That's the volume of a sphere. Clear? Now we look at the next sum. Now look at this sum, sum number 12. Log y plus 2 log x equals to 2. They have told express y in terms of x. Very easy. Can we write this as log y equals to 2 minus 2 log x? Now look carefully. Log y equals to 2 we can write log 100 because the base is 10, and this we can write log x square. So this becomes log y equals to log 100 by x square. And the bases are same. So we know if log x equals to log y and the bases are same, we can say that x equals to y. We have already done lesson 1, which means y equals to 100 by x square. And that's my answer. That's the relation between y and x. Okay. Now we look at the next sum. Now look at sum number 14. A square is given as log x, b cube is given as log y, and they have given a relation a square by 2 minus b cube by 3 equals to log z. They have told us to express z in terms of x and y. Pretty easy. Look over here. We'll take a square by 2 minus b cube by 3 equals to log z. Now a square I can write log x, half log x, okay, minus 1 by 3. B cube I can write log y, it's already given, equals to log z. The bases are 10 in all the cases. Okay. Now this I can write log x to the power half minus log y to the power 1 by 3 equals to log z. Now this log a minus log b is log a by b. So this I can write log x to the power half. Can I write root x? And y to the power 1 by 3. Can I write cube root of y equals to log z? Now look, log a equals to log b, which means a equals to b, provided the bases are same, and in this case the base is same. So we can say z equals to root x by cube root of y. Done. Now we look at the next sum. Now look at sum number 16. Log x equals to m plus n. Log y equals to m minus n. Express log 10x by y square in terms of m and n. Very easy. Look. Log 10x by y square. Can I write as log 10 plus log x minus log y square? Okay, this was single log. Expanded it. So this is 1 plus, so log x is m plus n minus, this 2 comes in front, this is 2 log y, this is 1 plus m plus n minus 2, and log y is m minus n. Now open the bracket, so this is 1 plus m plus n minus 2m plus 2n, so this is 1 plus 3n minus m. So that's my final answer. Clear? Now we look at the next sum. Now look at this sum, 17. If log x by 2 equals to log y by 3, find y to the power 4 by x to the power 6. Very easy. Look over here. We'll take this expression. Log x by 2 equals to log y by 3, which means 3 log x equals to 2 log y, which means log x cube equals to log y square. The coefficient becomes a power. Okay. Now this log a equals to log b. We can again write a equals to b, which means x cube equals to y square. Now squaring both sides, what you will get? X to the power 6 equals to y to the power 4. So if you take this over here, so 1 equals to y to the power 4 by x to the power 6. So y to the power 4 by x to the power 6 is 1. Done. Now we look at the next sum. You can pause the video and see the sum. Now look at 18 part 1. Solve for x. Log x plus log 5 equals to 2 log 3. Whenever this kind of question comes, try to express LHS and RHS in single log. Now log x plus log 5 in single log will be log x into 5. Okay. And this will be log 3 square, which means log 5x equals to log 9. Now log a equals to log b, which means a equals to b, so I can write 5x equals to 9, which implies x equals to 9 by 5, and that's my answer. Now look at 18 part 2. Log x minus log 2 equals to 1. The base is 3. Be careful, the base is not 10. What I can do, can I write this as log x base 3 minus log 2 base 3 equals to 1 into this? I can write log 3 base 3, because this is 1. Log of a number with the same base gives you 1. Can I write this? So now log, this becomes x by 2 base 3 equals to log base 3 3. Now we can equate. See, I needed to do this because if you equate log a equals to log b, then the basis has to be same. So we can say that x by 2 equals to 3, which means x equals to 6. Be careful with this step, okay? You can't write 1 as log 10 over here, okay? Because then the base is 10. Then we can't equate in this case, okay? Be careful, okay? Now we look at the next sum. Now look at 18 part 4. Log 8 by log 2 multiplied by log 3 by log root 3 is equal to 2 log x. We need to have single log on both sides. Now look carefully. Can I write this as log 2 cube by log 2 multiplied by log 3, and this is log 3 to the power half, and this is log x square. The coefficient becomes a power. Now this 3 comes in front. 3 log 2 by log 2 multiplied by log 3 by half log 3 equals to log x square. Can I write this? Now we can cancel log 2, log 2, log 3 and log 3 over here. Up and down, okay? Now 3 divided by half gives you 6 equals to log x square. Now look carefully. The base is 10 over here. Now 6, can I write log 10 to the power 6? Because as many zeros, the value is same. Log 10 is 1, log 100 is 2. So log 10 to the power 6 becomes 6. Of course, the base is 10 over here equals to log x square, which means when we equate, we can get x square equals to 10 to the power 6, which means your x is 10 cube, which is 1000. Done. Nice sum. Okay, now we look at the next sum. Now look at sum number 19. Given 2 log x plus 1 equals to log 250 bases are 10. Find x and log 2x. Very simple. We have to bring left hand side and right hand side in single log. Look over here carefully. This is 2 log x plus 1 equals to log 250 base 10. This we can write as log x square base 10. 1 we can write as log 10 base 10. Okay, this is equal to log 250 base 10. Now look carefully. Log a plus log b is log x square multiplied by 10 base 10 is equal to log 250 base 10. Now if log a equals to log b, we can say that a equals to b provided the bases are equal, which means 10x square equals to 250, which means x square equals to 25, which means x equals to plus minus 5. Now look carefully. If you put minus 5 over here, it becomes log of minus 5, which is not possible. So your x will be 5. Minus 5 not possible, isn't it? Now the second part, they've asked for log 2x. So we know the value of x. X is 5. So log 2x will be log 10. Okay, and log 10 is nothing but 1. Clear? Now we look at the next sum. Now look at sum number 20. If log x by log 5 equals to log y square by log 2 equals to log 9 by log 1 by 3, you need to find x and y. Easy. First of all, we equate these two. Can I write log x by log 5 equals to log 9 by log 1 by 3? Clear? Now this we can write log x by log 5 equals to, now log 9, can I write log 3 square? And you know log 1 by n is minus log n. So this we can write minus log 3, which now gives log x by log 5 is equal to, this becomes 2 log 3 by minus log 3. So log 3 cancels out. So what remains? Log x by log 5 equals to minus 2. Okay, now we can write this as log x equals to minus 2 log 5. Clear? Now this we can write as log x equals to log 5 to the power minus 2. Now log a equals to log b with the same base, we can say that clearly x equals to 5 to the power minus 2, which is x equals to 1 by 5 square, 1 by 25. That's your x. Okay, now we'll find y. Okay, now look, equating second part and third part, we can write log y square by log 2 equals to log 9 by log 1 by 3, isn't it? Now this becomes 2 log y by log 2 equals to, this we can write again, log 3 square, and this log 1 by 3 is nothing but minus log 3, this one. Okay, so this becomes 2 log y by log 2 equals to, this becomes 3 log, sorry, this is 2 log 3 by minus log 3. Log 3 cancels out, so this becomes 2 log y by log 2 equals to minus 2. Am I correct? Which means, can I write 2 log y equals to minus 2 log 2. Am I clear till now? Okay, now this, look carefully. So log y, 2 goes away, minus log 2, which means log y equals to log 2 to the power minus 1. Now we can equate y equals to 2 to the power minus 1, which means y equals to 1 by 2. Done. Clear? Now we look at the next sum. Now let us see sum number 21. Very interesting. Prove that 27 to the power log 2 equals to 8 to the power log 3. Look, how will I proceed? 27 to the power log 2 equals to 8 to the power log 3. Now I'll assume that this statement is true. Okay, now this is true. Taking log on both sides, taking log on both sides, what do we get? Log 27 to the power log 2 is equal to log 8 to the power log 3. This is also true. If this is true, then this is true, isn't it? Now again we can say that this power comes in front, so this becomes log 3 log 8. This is also true. So if this is true, this has to be true. Okay, now look over here. We can write this as log 2 log 3 cube equals to log 3 log 2 cube. So if this is true, this has to be true. Clear? Now look carefully, 3 comes in front, so this is 3 log 2 log 3 equals to, this 3 comes in front, 3 log 3 log 2. This is also true. Now look carefully, this is actually true. 3 log 2 log 3 will be equal to 3 log 3 log 2, which is true. Which is true. So we are going from here to here. See, if this is true, this is true, this is true, this is true, which means this is also true, which means we can say that 27 to the power log 2 is equal to 8 to the power log 3. Done? Clear? Now we look at the next sum. Now look at sum number 20, part 2. Solve log x plus 1 plus log x minus 1 equals to log 24. Whenever we have an equation like this, what we'll do, on the left hand side, on the right hand side, try to get single log and then we'll equate. So can I write this as log x plus 1 plus log x minus 1 equals to log 24. Now see, log m plus log n is log mn, so this will be log, and these two will be multiplied, x plus 1 x minus 1 equals to log 24. Am I clear? Now if you look carefully, this is log and this is a square minus b square. Okay, this is log 24. Now we know if log a equals to log b, we can say that a equals to b, which means x square minus 1 equals to 24, which means x square equals to 24 plus 1, 25, which means x equals to plus minus 5. Now if I put plus 5 over here, this becomes log 6, possible. If I put minus 5 over here, this becomes log of minus 4, not possible, which means x is 5, minus 5 not possible, because log of minus 4 does not exist. Clear? Now we look at the next sum. Now look at 20 part 4. Log 5 plus log 5x plus 1 equals to log x plus 5 plus 1. The bases are 10. Okay, so we can write this as log 5 plus log 5x plus 1 equals to log x plus 5 plus, now 1 can be written as log 10 to the base 10. Clear? Now log m plus log n, what do? You multiply, so 5x plus 1. Similarly over here, these two gets multiplied, 10 multiplied by x plus 5. Clear? Now we can equate them, log a equals to log b, we can equate a and b. We can say 5x plus 1 equals to 10 x plus 5. Now we need to solve it. This is 25x plus 5 equals to 10x plus 15, which is 15x equals to 45 if you solve it, which means x equals to 3. Done. Now we look at the next sum. Now look at 20 part 5. Log 4y minus 3 equals to log 2y plus 1 minus log 3. We need to solve for a y. Okay, now we can write this as log 4y minus 3 equals to log, and this can be written as 2y plus 1 by 3, isn't it? Log m minus log n is log m by n. Now we can equate 4y minus 3 equals to 2y plus 1 by 3. Okay, so this becomes 12y minus 9 equals to 2y plus 1. So this becomes 10y equals to 10, which means y equals to 1, and that's my answer. Clear? Now we look at the next sum. Now look at this sum. 20 power 6 log x plus 2 plus log x minus 2 equals to log 3 plus 3 log 4. Now this becomes log x plus 2 multiplied by x minus 2, isn't it? Log m plus log n is log mn, and this becomes log 3 plus log 4q. Clear? So this becomes log, and this becomes a square minus b square, because this is in the form of a plus b, a minus b, and this is log 3 plus log, this is 64, 4q. So this is log x square minus 4, and this is log, in single log it will be 3 multiplied by 64. Now we know log a equals to log b. We can equate a and b. We can say x square minus 4 is equal to 3 multiplied by 64. Am I correct? So this becomes x square minus 4 equals to, this is 192. So this is x square equals to 196, which means x equals to plus minus 14. Now look carefully. If we put minus 14, this log becomes negative, which is not possible. Log of a negative number is undefined. So x will be your plus 14 minus 14, not possible. Am I clear? So this is your answer. Now we look at the next sum. Look at this sum, very interesting. 23 log x plus 1 to the base 3 minus 1 equals to 3 plus log x minus 1 to the base 3. Now look carefully. Can I write this as log x plus 1 base 3? Bring this on this side. So log x minus 1 base 3 is equal to 3 plus 1, which means this is log, this is x plus 1 by x minus 1, isn't it? Base 3 is equal to 4. Am I clear? Now we can write this in exponential form. 3 to the power 4 is equal to x plus 1 by x minus 1. Done. Now look carefully. This is 81 equals to x plus 1 by x minus 1. So this becomes 81 multiplied by x minus 1 equals to x plus 1, which means 81x minus 81 equals to x plus 1. Clear? Which means 81x minus x equals to 1 plus 81, which is 80x equals to 82, which means x equals to 82 by 80, which is 41 by 40, which is 1 by 40. Clear? So this is your answer. Now we look at the next sum. Now look at sum number 24. 5 to the power log x plus 3 to the power log x equals to 3 to the power log x plus 1 minus 5 to the power log x minus 1. What I'll do, 5 to the power log x, I'll bring this on this side. So this becomes 5 to the power log x minus 1 is equal to, I'll take this on that side. So log x plus 1 minus 3 to the power log x. Clear? Now look at one thing. If something is x to the power m minus n, you can write x to the power m by x to the power n, isn't it? So we can write this as 5 to the power log x by 5 to the power 1. So 5 to the power log x plus, this becomes 5 to the power log x by 5 to the power 1, which is 5 only. Similarly this we can write 3 to the power log x multiplied by 3 to the power 1, which is 3 minus 3 to the power log x. This one was what? A to the power m plus n is equal to a to the power m multiplied by a to the power n, isn't it? And this was a to the power m minus n equals to a to the power m by a to the power n. Clear? Now look carefully. If I take 5 to the power log x common, I'm left with 1 plus 1 by 5. Similarly over here, if I take 3 to the power log x common, I'm left with 3 minus 1. Am I clear? So this becomes 5 to the power log x, and this becomes 6 by 5 equals to 3 to the power log x. This becomes 2. Clear? So what I'll do, I'll write 5 to the power log x, bring this over here, so 3 to the power log x equals to 2 multiplied by 5 by 6, which is how much? Which is 5 by 3, which means this, can I write this as 5 by 3 to the power log x, and this is 5 by 3 to the power 1. 5 by 3 we can write as 5 by 3 to the power 1, which means if bases are same, we can equate the power. Log x equals to 1. We know the base is 10, so we can write x equals to 10 to the power 1, that is 10. So that's your answer. Clear? Now we look at the next sum. Look at sum number 25, very interesting. Given log x minus y by 2 equals to half log x plus log y, prove that x square plus y square equals to 6xy. Now we'll start from here and try to get this equation. How? Just look over here. Given is what? Log x plus y, x minus y by 2 is equal to half log x plus log y. Now we can write this as this 2 comes over here, 2 log x minus y by 2 equals to log x plus log y. Look carefully. So this we can write as log x minus y by 2 whole square equals, and this is definitely log xy. Now we can equate log a equals to log b, we can equate a and b. So x minus y by 2 whole square is equal to xy. Now we'll just expand it. So a square plus b square minus 2ab by 4 equals to xy. Look carefully. This 4 goes over there. So x square plus y square minus 2xy equals to 4xy. This becomes x square plus y square equals to this minus 2 goes over there, becomes plus 2, 6xy. That's proved. Done. Now we look at the next sum. Now look at sum number 26. Given x square plus y square equals to 23xy, we need to prove that log x plus y by 5 equals to half bracket log x plus log y. So we need to start from here and end over here. How? Just the reverse of what we did in the previous sum. Now in an equation we can add the same term on the left hand side and on the right hand side. So if I add 2xy on both sides, so this becomes, look carefully, and this becomes 23xy plus 2xy. So this becomes x plus y whole square, and this is 25xy. Clear? Now this I can write as x plus y whole square by 25 equals to xy. Now this I can write as x plus y by 5 whole square equals to xy. Now what I'll do, I'll take log on both sides. So taking log on both sides, I get log x plus y by 5 whole square equals to log xy. Now look, this 2 comes in front, so this becomes 2 log x plus y by 5, and log xy will be log x plus log y. Clear? Now this becomes log x plus y by 5 equals to half log x plus log y. Okay, and this is what they have asked to prove. Done? Clear? Now we look at the next sum. You can pause the video and see the sum. Now look at 28 part 2. They have told us to prove that 1 by log 36 base 8 plus 1 by log 36 base 9 plus 1 by log 36 base 18 is equal to 2. Now look at this one, the base changing rule. LHS first. Your LHS is 1 by log 36 base 8 plus 1 by log 36 base 9 plus 1 by log 36 base 18. Now this can be write as log 8 base 36 by base changing rule, this one, plus similarly this one can I write log 9 base 36, and this one can I write log 18 base 36. Am I clear? Now look carefully. Log a plus log b plus log c, same base. We can simply write log, this is 8 multiplied by 9 multiplied by 18, 36. Now this, if you look carefully, 8 multiplied by 9 multiplied by 18 will give you 1296. Now 1296 is nothing but the square of 36. Done? Now this 2 comes in front, so this is 2 log 36 base 36. Now this is 1, so this becomes 2. Clear? Now we look at the next sum. Now look at 29 part 2. Log a base b log b base c multiplied by log c base d is equal to log a base d. Now we'll take the left hand side, is log a base b multiplied by log b base c multiplied by log c base d. Now by base changing rule, can we write log a by log b, isn't it? This we can write log b by log c. This I can write log c by log d. I can take some common base, for example k. Okay, base is same. Now what I can do, look over here, log b cancels out, log c cancels out. So this becomes nothing but log a by log d base k. Now again this I can club and write log a base d by base changing rule. True. This is your RHS. Clear? Now we look at the next sum. We look at sum number 30. Given that log x base a is 1 by alpha, log x base b is 1 by beta, log x base c is 1 by gamma. You need to find log of x with the base abc. No worries. First see. Given log x base a equals to 1 by alpha. Am I clear? Now this by base changing rule, can I write log x by log a equals to 1 by alpha? So this I can, alpha comes over here, alpha log x equals to log a. Similarly for this I can write beta log x equals to log b. Similarly for this I can write, see, gamma log x equals to log c. Now look what they have told us to find. They have told us to find log x base abc. Now this can be written as log x by log abc, which in turn can be written as log x by, this is log a plus log b plus log c. Am I clear? I will just substitute the value. So this is log x. Log a is what? Alpha log x plus beta log x plus gamma log x. Now from the denominator, if you take log x common, so this becomes alpha plus beta plus gamma. Now this cancels out. Definitely log x not equal to 0, which means this becomes 1 by alpha plus beta plus gamma, and that's my answer. Okay, you can pause the video and see the sum. Now look at the last sum. Log x base 2 plus log x base 8 plus log x base 32 equals to 23 by 15. We need to find the value of x. Now by base changing rule, can I write this as log x by log 2? This I can write log x by log 8. This I can write log x by log 32 equals to 23 by 15. Now look carefully, this I can write log x by log 2 plus log x. This 8 can I write log 2q plus log x by log 32. I can write 2 to the power 5 is equal to 23 by 15. Now look carefully, if I can write this as log x by log 2 plus log x. 3 comes over here, so this becomes 3 log 2. Similarly, this becomes 5 log 2 equals to 23 by 15. Now look carefully, can I take log x by log 2 common? So what is left? 1 is left over here, 1 by 3 is left over here, 1 by 5 is left over here, equals to 23 by 15, which means log x by log 2, and this is 15, so this becomes 15 plus 5 plus 3 equals to 23 by 15. Now this becomes log x by log 2. This, if you solve, this is 23 by 15, isn't it? And this is equal to 23 by 15. So log x by log 2 equals to 23 into 15 by 15 into 23, which is equal to 1, which means we can say log x equals to log 2, which means we can say x equals to 2. And that's my answer. Clear? Now this was the last sum for this chapter.